Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. This week we're answering this question sent in by listener Dan.
Hi Naked Scientist. Why do ship propellers propel the vessel from the rear when aircraft propellers do the same job from the front? Has it got something to do with the different viscosities of water and air? Thanks, great show.
Good question, Dan. As it turns out, there are quite a lot of answers to this question, in which physics and practicality go hand in hand. Some aircraft have their propellers closer to the front because goods are often loaded on and off at the back, and putting humans near spinning blades isn't always a sensible idea. It's also common for boats to have propellers at the back to avoid them bonking into things and breaking. Halk on the forum also points out a small boat tends to lift its bow out of the water at high speeds. Not a good thing if the propulsion is there, which is a very fair point. But there are also good physicsy reasons for these respective propeller placements. So a big thank you to Cambridge University's Andy Wheeler, who's here to talk us through them.
The big difference between water and air is that water is very much more dense than air. So if you take a metre cubed of air, it weighs about 1 kilogram, and a metre cubed of water weighs about a tonne, so 1,000 times more. So that means that propellers for aircraft need to be much bigger. And that's because the thrust you get from a propeller is related to the amount of the mass flow that passes through the propeller and the speed with which the propeller can push that backwards. And so that can affect practically where you could put propellers on an aircraft. You couldn't have a propeller that was too close to the ground that might then hit the ground, or towards the back of an aircraft that might affect how the aircraft could land. But of course, the propeller is also attached to an engine, and the engine tends to be heavy, and the distribution of weight on an aircraft is very important. So if you have too much weight towards the back of an aircraft, that will affect how the aircraft can be controlled in flight.
And is there a case of there needing to be the right sort of air flowing through an engine?
That's right. So quite important to the performance of a propeller is how the flow is entering the propeller. If you were to put a propeller behind something, and so the flow coming into the propeller was very distorted, that would affect the performance of the propeller. The propeller on the boat, because the water is 1,000 times more dense than air, it's much smaller. And you tend to mount that at the back of a boat. And I think that's more to do with where you'd want to mount the engine. So for instance, on a small boat, you might want that boat to pitch up a little bit, so the weight of the engine can help with that, so that the boat can then move more smoothly through the waves. So the viscosity isn't really the main thing that affects these big decisions on where you put the engine and the propeller and how you distribute the weight, for instance, in each case.
I did anticipate this being far more a physics question, but it does seem to be more one of a practical applicational question.
One thing I'd like to say is that actually there isn't really any physical principle that tells us we can't put an aircraft propeller at the back. I mean, you'll see some aircraft do have propellers at the back or have jet engines at the back of the aeroplane. And as we move towards more futuristic propulsion systems, we might start to see more electrically driven propellers. And those can be made much smaller, and they can be distributed over the aeroplane. And that gives us a much bigger degree of flexibility in the design of the aeroplane. So we could have small propellers mounted on the wings, for instance, and that can help to blow air over the wing to improve the performance of the wing.
So there you have it. Thank you very much to Dan for the question and to Andy for the answer. Next week, we're answering this question sent in by listener Kate, who asks,
how do parasites understand that they have fallen into a host and that they reach their final or intermediate host?
And if you think you know the answer or have a question of your own, do feel free to get in touch. The email address is chris@thenakedscientists.com, or meet like-minded scientifically curious minds on our forum, nakedscientist.com/forum.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.